Yeah. Hello, my name is Felipe Hoffa, as you might know. I'm Chilean. I grew up in Chile. Then 7 years ago, I moved to San Francisco. And now I'm super happy to be here. Who went to the party last night? Good. Okay, so not everyone. Most people that went to the party are not here, but thank you to the ones that woke up. I appreciate it. I didn't go, so I could be ready for you today. So we're going to talk about analyzing data. I love analyzing data. We're going to use GitHub and some of my favorite tools, and I'll be waiting for your questions. What do you see here? What is this? What do you see? Python, code, yes. So we see code, but not only code. We see a license, we see a copyright year, we see some imports, some are from the future. If we go back, we look at the big picture, we see more data, the number of stars, the number of forks, how many pull requests, how many people have contributed. What I want to show you here is that what I see here is data. And with a big font, because this is big data. Thanks. And the question is, who wants to analyze GitHub? Project maintainers. If you have a popular project, you might know who is following you, who cares, who will you break if you change your project? Is your project healthy? But also project users want to know this. If you're using any popular project, you want to know the best way to request features, what other projects are interesting for you. And before you are a project user, you are a project chooser. You want to choose maybe the most popular and healthy project. You want to see what your alternatives are. And even if you are neither of these, just if you love data, I have here a lot of data that it's super interesting to research. So let's get started. There are three main data sets I'm going to be talking about today, and some more. But the three main data sets about GitHub. One is the GH archive, previously known as GitHub Archive, that has more than 1.4 billion events, updates hourly. And then there are other data sets like GHTorrent. This one brings more data in, annotates, traverses the graph of knowledge within GitHub. It gets real-time updates. And we also have a copy of GitHub's code inside this tool. So you can analyze 46 terabytes of code with simple SQL. Everyone here knows SQL? Who knows SQL? Who is awake? Yes, most of you. Excellent. Excellent. So just to get started, as an inspiration, you know what are the top companies contributing to GitHub? Any guess, if you had to guess the top companies? Google, I love that one. Microsoft, a lot of people read that article. So I went and searched the data and I looked into many dimensions and I got this chart. And as you can see, yes, Google and Microsoft are at the top right. And on this dimension on the bottom, I'm measuring how many people from each company I could find. And I could find more people from Microsoft. And then from the bottom to the top, I'm counting the number of projects. And Google shows up with more projects on GitHub. And then the size of each circle means how many stars these projects have collected. And Google has collected a lot of stars. Now, there's a lot of other interesting companies contributing. You can see Apache, GitHub, Red Hat, IBM, Facebook, Intel. And it's really interesting to see that, yes, there is a lot of contribution to open source, but there are two companies dominating this space. To do this analysis, this was my SQL query. And it looks a little complicated, so before going there, before getting deeper analysis, let's get started with the basics. How do we got here? Back in 2012. Do you know this guy? This is Ilya Grigorik. He was presenting to you 2 days ago. And he doesn't only know a lot about the web, he also started collecting GitHub events 5 years ago. And He made it very easy for anyone to download these events. You can download any file for every hour. If you download one of these files, it will take you less than 1 second. 1 hour of data takes 5 megabytes of compressed data. And if you decompress it, it's 4 megabytes of compressed data. So this is super easy to download and analyze. But if you want to do the same with 7 years at the same rate, suddenly we're talking about more than 1 billion events, more than 2 terabytes. And the question is, where can you analyze and host that kind of data? What's your answer? I like the second one better. So BigQuery is one Google tool that also was getting born at that time when Ilya started doing this. And if you don't know BigQuery, it basically allows you to analyze terabytes in seconds. It's simple. You just need to know SQL to use it. It scales to petabytes. It's always on, so you don't have to pay per hour or anything. It works with Tableau, with R, with Python, with Data Studio, with Power BI, any of your favorite tools. And some features that are really interesting is that you can share. Data that is stored in BigQuery is private, but if you want to share it with anyone else, any other company, any other friend, or with the whole world, you can do that. And everyone gets a free monthly quota. Everyone has a free terabyte every month to run these queries, so feel free to replicate and question anything that I do. I might not be right, but you can see if I am or not, and tell me if I'm not. So Ilya decided to use BigQuery. He stored all of this data of GitHub in BigQuery, and now you can go and query it to see what's happening right now until the last hour. Let's start by looking at the stars. What stars am I talking about? GitHub stars. Yes, people love GitHub stars. So for example, if we want to see the top projects by stars in 2016, the result was this. First one was Free Code Camp, Google Interview University, Vue.js, TensorFlow, etc. But you might want to know the results for last year instead. So let me write some live queries. I have BigQuery, the web UI here. I have the GitHub archive, let's see, 2017. I have a lot of data sets, and GH archive is here, 2017. We will write a query on this table. Is the internet working? I think it is, but the table is not loading. Let me open a new tab, and we can come back here. Loading BigQuery, this is loading. Now I have the table. This is March 2013. Let me get a table with all of 2017. This table last year has 400 million events, a gigabyte of data, and if you want to know what are the top projects, you just do something like count star, and you get the name of the project, which is the repo.name. And we look for events of the type where type equals watch event. This is a star. And then we group by the repository. We order by the count in descending order. We get the top 20. And do you know what were the last 20 projects of last year? And how long does it take to run this query? Again, Free Code Camp, followed by TensorFlow, Vue.js, Facebook React. It's similar results. Things move anyways. Now, whenever you run any analysis, and this is important to remember, you have to start thinking, are these really the right results? Am I getting the answers I want? And this is the case if we go to GitHub. For example, this is my repository, my own repository, and I have a repository about analyzing GitHub. So if you want to see more of these links, you can come here, and you can start my project. And then you can remove the star, and you can start it again. And you can remove the star, and you can start it again. And every time I do this, I'm creating a new watch event. So I'm creating a lot of fake stars. So if you want to get all of those stars out of your analysis, you can do something like count the number of distinct people doing this analysis. And now we will order by that column. And you will see that a lot of stars disappear. There's a lot of projects with fake stars. So free code camp goes from 90,000 to 84,000, 49 to 43,000. There's a lot of duplicate stars. Always try to think how statistics are fooling you. By the way, do you know why free code camp gets so many stars? They are an awesome project about how to learn to code. A lot of people are using it. I love them. Now, the first step in the instruction manual is create a GitHub account. The second step, you know what it is. Exactly. They stopped doing that, so they are going lower in the rankings, but they are asking people to start their project, and they get a lot of stars. Again, if you want to do the same for the last 12 months, you can run a query like this, and this query will show you what has been happening in the last 12 months. Just for the fun of it, let me copy the query. And now with this SQL, I can ask for every table from the 2000s, but only the ones between 1706 and 1805. And you can see that the top project now is Vue, followed by TensorFlow. Now, are these the real results? No, because I didn't remove the duplicate stars. So this is just to know if you were paying attention. If we remove the duplicate stars, which I'm going to do now, you can find that the top project for the last 12 months was, TensorFlow, just by removing the fake ones. So yeah, your results will change, and still, all these projects are super interesting, and in the last 12 months, we got new projects on the top 10, like Google Chrome, Puppeteer, and X64 DVD. Now, not all stars are equal. A star I give a project is different than a star that you give. Stars that you give are different because each of us is different. We have different interests. We have been coding for a different length of time. So if you're looking at the stars for any project, you can look at more dimensions. For example, FreeCodeCamp in 2016 got 170,000 stars. TensorFlow got 24,000. But the people behind each of these projects is different. Again, you can run a query like this one. We will copy it in BigQuery. And what I'm looking here is at many dimensions. How old are the users behind each project? How do I know the age of users? I don't know the age of users. But I can see how long they've been active on GitHub. And turns out people on TensorFlow have been active twice as much as people on FreeCodeCamp, which makes sense because TensorFlow is an advanced project and FreeCodeCamp is a project for beginners. You can see that TensorFlow people have started more projects, issued more comments, been active in more places. So in this way, you can create rankings for your own projects, the rankings you are interested in, is your audience. And things change. The top 10 is if you only look at people that have written more than 20 comments in issues. The top project in 2016 was Yarn. We have a different ranking within people that have more experience. Now, can we trust stars? A lot of people are like, why are you counting stars? They might not be a very good measure. I was looking at this project. This organization has 240 projects, and I wanted to know what was their most interesting project, so I counted the stars for each of their projects, and this is the result I got. Most of their projects have 250 stars, and that doesn't make a lot of sense. So you can do things like, oh, let's remove all the fans, everyone that is starring every project, and you will get a lot more interesting results if you try to fight things that might not be giving you the results you want. Now, by looking at stars, you can find other different things. For example, TensorFlow people. If you start TensorFlow, what else did you start? And you get these other popular machine learning projects. Pretty interesting. You can also run a ranking instead of just counting stars. You can look at probability of having the other stars. The rank is different, and it gives you other projects more related to TensorFlow. And you can do this for any project you are interested in. You can find the timeline of stars. Most projects don't get the stars, 10 stars every day. They get peaks, like this. These are Apache projects. This chart I made with Data Studio. And you can see that, yes, some projects are very stable, but some peak. Especially interesting here is, for example, Flink, that gets a stable number of stars, versus Arrow, that got a lot of stars each time Wes McKinney wrote a blog post. And then you might wonder, so how did people find your project? For example, this annotated timeline shows, any of these annotations shows anytime these projects got into Hacker News. You go to the Hacker News front page, you get a lot of stars. What's even more interesting is that I didn't annotate this manually. What's interesting is that I have Hacker News also in BigQuery. So you can start running joins and finding when the effect that Hacker News has on projects. And it just takes a query like this. Project health. What projects are more healthy? Here I'm counting the projects that had the most number of comments on issues on June 2016, just to do any month. And you can see, the top project that month was Kubernetes, followed by Spark, followed by OpenShift, followed by Sauron Demo. Anyone knows that project? Again, adversarial metrics. Why is this project on top? Instead of counting just the number of issue comments, count the number of people commenting on each project, and you will get a result like this. And what I did here is not only count the number of authors, Kubernetes has 500, Font Awesome has 600, but if you divide the number of comments per author, you get that Kubernetes gets 18 comments per author. Like these 500 people were writing in average 18 comments each. That's a super healthy community. While Font Awesome was getting a lot of people commenting, but each one wrote less than 2 comments in average. That's a different kind of health. And I'm super happy to see Google projects like Kubernetes and TensorFlow on top. Also Microsoft VS Code and Facebook React Native. They have a super healthy community. You can go deeper. Until now, I've been only counting and joining stuff. You can do text analysis. For example, every time someone starts an issue, what are the top 4 words that people are using? These are. It would be nice. Is it possible to? I'm trying to. People are nice in Stack Overflow, which is nice. Now, are they effective? I want to know how many of these issues get closure. It would be nice to get 56% closure, while is it possible to? 73%. The best one is to say, I get the following. Just be concrete. What's your problem? What are you getting? What do you want? And people will have a way easier time answering your questions. There's one hidden one there that you might notice. It's your homework to guess why the humans get that rate of closure. Top countries. You can look for the top countries because we have more data. Everyone on GitHub, on their profile, writes if they want what country they're from, and we can use that data and aggregate it. Thanks to GHTorrent. We have here, for example, the top countries. And the top one is null, because a lot of people don't enter their data. But if you do, you will find, of course, the US, India, China, the largest countries. But you can go deeper. You can do per capita. So for example, this is just counting the number of pushes. The United States is on top with the dark green. But if you divide per capita, then you see that Europe goes way darker on the green. The ranking says that the GitHub active users per capita ranking in 2017, the top countries were Iceland, Sweden, New Zealand, Norway, Switzerland. Basically, cold countries. Do you agree? Well, we can go deeper. I have all weathers data in, well, these are other countries if you want to see your own, but we can come back here in questions. But let's talk about weather. Do we like cold countries or hot countries? Where would coders go? On BigQuery, I have the everyday's weather for the whole wide world. So I took every station for every station, and I averaged it per country. So you can go from Greenland, Mongolia, and Canada there to Singapore, Senegal, Chad on this other side. And it kind of makes sense. We can join both data sets, and I get a chart like this. Yes, cold countries there on that side have the major concentration of programmers versus hotter countries on this side. They have a lower concentration. If you're looking Austria, Austria is there, right next to Czechia. Czechia, how do I pronounce it? New country. But you can see that Europe is there. Sorry, you will teach me later. And super interesting on the other side, within the hot countries, Singapore is super hot, but also has a super high concentration of programmers. So you can find your level of comfort and how many coders you want to see in this map and go to that country. We want to go count developers in Europe. OK, I can do that with this query. And yes, on top we have the UK, Germany, France, and I can compare it with other data sets. Joel Spolsky will be speaking later, so let's look at Stack Overflow, which I also have on BigQuery. And we get a similar ranking. United Kingdom, Germany, France, Russia, Netherlands, some things move there. But at least we're getting two different sources to compare stuff. And with the Stack Overflow, I can look at the growth. What are the countries getting more users from 2016 to 2017? On top, with the highest growth, Portugal, followed by Lithuania, France, Ireland, Romania, Greece, Ukraine. How many Ukrainians in the house? Just wondering. Hey, thank you for doing Stack Overflow. And on the bottom, we have Belgium, Denmark, Sweden. Why these countries are getting not so much growth, according to my stats? Ask Joel later today. I'm really interested in the answer. Let's talk a little bit about code. Where is the code to do all of this? So we announced a couple of years ago that we had copied GitHub's code, the open source part, to BigQuery, and now you can analyze it. When I took this screenshot, this table had 200 million rows, 1.79 terabytes of data. And that's because we have each unique file only once. So if you want to deduplicate them, you can multiply. Here you have the content of the table, you have the ID of the file, the size, the content. So if you want to know how many, and the number of copies, you want to know the number of files total, you can sum the total size per the number of copies. And last night I got to almost 50 terabytes of code that you can analyze in real time. These are the basic rules. It has text files of less than a megabyte, one unique copy. You can join with another table to get the path of each file. My biggest recommendation here is extract first. If you only want to analyze Java code, extract all of the Java code first, and then your free terabyte each month will last a lot longer. And I already did that for you in many cases. If you need more, feel free to ask me. I'm on Twitter. I will be very happy to create more extracts. And we only have open source projects where we know that they have an open source, valid open source license. Now you can do stuff like go line for line in each Java file, look at only the lines that say import and see what are the top imports. And let's compare the growth between 2013 and 2016 in Java. The top growth we got on injection, on Android imports, build, nullable, and also Mockito tests. People were started doing more Mockito tests. And you can do this for any language you are interested in. But you can also search other things, like let's go back to Stack Overflow. When people get code from Stack Overflow, they sometimes link back to where they got their code from. So with this query, I'm looking for any link in JavaScript code to Stack Overflow to find what questions get the more links. And these are the top questions from the JavaScript world. They want to know if there is a escape function in JavaScript, how to convert a decimal to X, And we can compare not only the number of files linking, we can also see how many views each answer is getting. So by number of views, the top one is how to convert a decimal to X in JavaScript. You can find that kind of thing. Now, you may be wondering the opposite. How many people copied their code from Stack Overflow? Okay, that's nervous laughter. Turns out Sebastian Valtes, he had that question, and he went to one of the top Stack Overflow answers and saw this code, and he wanted to find how many people have copied this code. Now, searching for text is not that easy because people change the name of the variables or do stuff like that. So he changed that code into this regular expression. And with BigQuery, he can search for regular expressions. He found this in more than 400 Java files. Only less than 30% give any credits. And all matches did look like a copy of Stack Overflow's code. So if you know anyone that copies code from Stack Overflow, just tell them to give them credit to the original answer, or Sebastian will find you. Okay. Now, when you request new features, you want to be effective. For example, someone here, Sam was talking to the Go team, and he was asking, I want to write after time until instead of now I have to write after expiration time's up. Well, it looks prettier, but is this a valid request? Should the team implement this? So my friend Francesc, who was in the Golang team at that time, he went and counted how many projects would benefit from this feature. He got more than 2,000 repositories that would benefit from this. So the Go team went and implemented these changes. And the super important message here is that just by open sourcing your code, just by putting it on GitHub, you are passively voting. People, project maintainers, can see how you're using their projects, and they can improve their projects according to what you are telling them, even passively, just by sharing what you do. Someone else was asking to normalize TLS config because sometimes they use caps, sometimes they don't. And Francesca again found that many repositories would be broken if we fix this. So the team has not fixed this issue. Again, you're voting by sharing your code. You can go beyond regular expressions. With BigQuery, you can do SQL, you can do regular expressions, but you can also run arbitrary JavaScript code inside SQL. Those are user-defined functions. So for example, to do static code analysis, I just took a library I found on GitHub, JSHint, and I told BigQuery, take this library, run it inside my SQL query. This was my code. And suddenly I'm getting the top warnings a static code analyzer gives me for JavaScript. There's a lot we can do with UDFs. I would love to talk more about that with you later. You know this guy? Steve Wozniak, he was presenting here also 2 days ago. People were asking if he was happy. What's his favorite programming language? Someone told him he's from the past. But people really wanted to know the answer to tabs versus spaces. 226 votes. I don't know his answer, but I have an answer for you. Because I have a lot of code to answer it. So I wrote this article looking at 400,000 repositories, 1 billion files, 40 terabytes of code. These were my rules. I will look only at the top 400,000 repositories by number of stars. I will look at files that are longer than 10 lines, 1 vote per unique file. We'll look at the top languages. And I wrote that in one query. First, I extracted the languages I wanted to analyze. Then I applied my rules, just SQL. And these are the results. In Java, people prefer spaces to tabs. In C, 50-50. In Ruby, just spaces. And if you really like tabs, learn how to code Go, because they only accept tabs. Thank you. Woo. Go spaces. OK. People have used this project to do solve other problems, like security issues. This was a group of 50 Googlers that found vulnerabilities in GitHub's code to the Mad Gadget project, and they used BigQuery to search and solve these problems in a lot of projects. But also in important questions, this is a very important one for me. Do you put your commas at the end or at the start of SQL? Start? And who puts the commas at the end? Who puts the commas at the start? Okay, so we are the minority. Let's analyze code. This is my query. And I got that, yes, a lot more people put their commas at the end. But I was not ready to give up. What projects are more successful? And how do you even measure success? More stars last year, number of contributors, activity. So I went and I ran this query, huge query. I got these results, and my results are that projects that allow commas at the start are double as successful. So yeah, start putting your commas at the start, at least in SQL. Your turn. Stay curious. Maybe you don't trust my results. Feel free to query and run under different assumptions, and let's discuss using data. And also show up. If you want your interest to show up, if you want project maintainers to know what you're doing and do things the way that would benefit you, show up. Show up on GitHub, show up on Stack Overflow, tweet, blog, because people are listening, and we are giving them tools to listen to you, so your opinion, so your vote, so your needs count. So who wants to analyze GitHub? I hope everyone here. Even GitHub uses BigQuery. I ran this video with Allison, one of their data scientists, and also project maintainers, user choosers, data lovers, and hopefully you. There's a lot more than people have done. This is only a fraction. I collected some links. I'll be happy to share them. They are on my blog post. And if you have any questions, you can find these links to the articles I used to write this on this repository. You can find me on Reddit. You can find me on Stack Overflow. You can find me on Twitter. And if you have feedback for me, I love feedback, you can use this URL. So thank you very much.
You can ask some questions.
Yes,
thank you very much. Felipe Hoffa.
Yeah.
So, actually, we have a couple questions from the audience. Some of you have been using Slido for Q&A. Maybe stand over here. So, there's a couple of questions. First of all, I mean, it would be nice. Think of what you would say to Steve Woz. It would be nice. And to your response,
yes.
What would you tell him?
It would be nice if you follow me on Twitter. Thank you.
Okay, the next one. Actually, some really good questions. How long will Google plan on supporting BQ? Because Google has a tendency to start awesome projects and then not support them. So,
yes. I still miss Google Reader a lot. But BigQuery is one of the fundamental pieces of technology we use inside Google. We are using this since many years ago because that's the only way we can analyze data of this size. And with cloud, we are super committed. We are doing a huge investment, so you can be rely assured that BigQuery is here to stay, and it's only growing more awesome every year. I promise you that.
So I think actually this question has probably been answered. Have you checked whether tabs or spaces correlates with default settings on popular IDEs?
Probably, yeah. So IDEs are choosing spaces for most people, but some people still go and do tabs if they want to. You can change your popular IDEs too.
Okay, another is, will BigQuery support UDFs in other languages?
Yes,
like
so the first question is why BigQuery does JavaScript and not Python. Python is a better language for data science. Turns out Python is a little slow, and in BigQuery we want things really, really fast. Now, why is JavaScript fast? How are we running JavaScript inside BigQuery this fast? That's because Google also has Chrome, v6, and we are running the same JavaScript runner that we did for Chrome inside BigQuery, and that allows us to go really, really fast in a secure way. So yeah, I would love Python, but you can do Python outside BigQuery and run JavaScript inside. Now,
next question.
I have an interesting answer for that.
Please.
Something that we just developed with Francesc. In JavaScript, you can run a WebAssembly. So you can compile C, Rust, Go to WebAssembly, and then you can run that inside BigQuery, and we just publish that solution.
Now, an interesting question. What percentage of code are comments?
I would love to answer that, but if we have time, we can run this query. If not, we can follow up on Twitter.
We have time.
We have time. Oh my God. This is my fault. So how would you analyze this?
We need to switch back to his.
But let me get started. We can do the rest later. But just to show you how I would do this, I have the project FH BigQuery. This is my own. Here I have all of Java for 2016. And each one of these lines has Java code. I can take this full Java file. I can split it by new lines, and I can look at the first two characters. Do they start with a comment or not? And then I can count the percentage of lines. Now, that's an easy regular expression, but it will only get me half of the results, because regular expressions cannot find maybe comments that start with /* and then with */. So maybe just to get the best answer there, I would look into a static code analyzer. I would write some JavaScript code just to find strictly what is comment and what is not with a parser.
Awesome.
Aha.
Thank you very much.
Thank you.
We do have other questions, but you're here the rest of the conference?
Yes.
Congrats. We have 3 or 4 more minutes. Should I take a couple questions? Okay. So the next one would, did you do queries on trending programming languages and usage in most starred repositories?
Yes, I did that. I don't have that article now, but it's super interesting to look at these results and compare it also with the Stack Overflow. The latest thing I'm running is, maybe I have we have Data Studio, that is our free visualization platform. And I'm visualizing here what people are doing on Stack Overflow. So here, for each tag in Stack Overflow, I'm looking at the number of views quarter for quarter to see what are the most popular tags. And I can run anything I want. So for example, if we just compare Java with JavaScript, in the number of views those answers are getting on Stack Overflow, the results are this. And if you want to compare it with anything else, let's add Python to the mix. The results are this, as soon as they come. Python is, if you can see here, Python is just growing, and catching up. It caught up to JavaScript, and soon it will catch up to Java, probably. And you can do this for any Stack Overflow tag, and I will soon release this study.
Awesome. Back to the questions. We have, this GitHub repository is very openly available. How do we discover other similar repositories or data sets that are available on BigQuery?
Excellent question. So on one hand, we have our official program where we have some official data sets, and we publish all of that. But then for anything that's not official, I also run this subreddit, BigQuery, where you can find the latest news about BigQuery. I publish here all the new data sets. And I also have this wiki inside, wiki data sets, where every time I know of a new unofficial data set, I just paste it here, and you can find a lot of interesting data. And you can add more, because you can store data for free up to 10 gigabytes in BigQuery and share it with everyone. And they get a free terabyte for queries.
Awesome. Next question. Someone is trying to move their org to use, or to whatever their organization, to try to encourage them to use BigQuery. But organizing SQL code for reuse in Git is a little bit awkward. So what are the best dev tools for collaborative BigQuery use?
Yeah, for collaborative BigQuery use. There is a project, they are open source, I love them, and they are called Redash. You can find them here, they have a demo, they connect to a lot of databases, including BigQuery, and they are really good for teams, for building dashboards, for sharing queries. So let's see. Well, this is their demo. You can find, let's see if maybe they dump the ones I have installed. But this is a really nice open source tool that you can even improve for your team.
Okay, last question. Actually, this is kind of a cool question. Have you used mining software repository techniques to understand more data or just playing around with BigQuery? Or in other words, like, what do you do besides playing around with data? Do you have a life?
Yes,
you seem to enjoy
I did not go to the party yesterday because I was playing with data. But these tools, these numbers are really useful for people that want to do stuff. For companies that are building projects for you, for our users, choosers. But I would love to go deeper if I understood where the question wants to go.
Yeah. Felipe Hoffa from Google, thank you very much.
Thank you very much. Thank you, everyone. See you later. Thanks.
Bye-bye.